Welcome back to Smart Interviews YouTube channel. This is 𝗟𝗲𝗃𝗲 Singh. Let's solve some problems from Starters 199. Let's get started. Let's start with the first problem. The problem name is cake making. There are 100 colors in the world, numbered from 1 to 100. Chef is making a two-layered cake. All that is left is deciding the colors of the two layers. Okay. Chef has decided that we can choose any of the two colors from 1 to A for the first layer and any of the colors from 1 to B for the second layer. So I expect that they will be giving A and B in the input as they are giving A and B in the input. However, there is a constraint. To encourage diversity, the first and second layer should not have the same color. That means if the first color is 1, the second color should not be 1. So yeah, let's see. You need to output how many different cakes are possible while following the above rules. So two cakes are said to be different when the first and second layer has different color. Okay, that's cool. Let's come to the output. In the sample one, they have clearly given that my A is 2, my B is 3. So if you observe this, for first layer I can have options 1 and 2. For third layer I can have options 1, 2 and 3. So following the above rule, if I try to make the permutations, basically I am going to form the permutations. So I can, what are different kind of permutations for these values? It can be 1 and 1, 1 and 2, and then 1 and 3, 2 and 1, 2 and 2, 2 and 3. Out of this, obviously we should not have first and second layer same. So I can call this as first layer and this as the second layer. So these two are same. These are not valid according to our condition. And these two are same. So if I remove these two, the remaining possibilities are 4. That's the output. If I take the A and B as 1 and 1, the possible things are for first layer 1 and 1 are possible. Second layer 1 is possible. So out of these two, there is only one combination possible, which is 1, 1. But it is not valid. It is an invalid combination. Let's see one more example. With this, the idea will be more clear. If I have A as 100, B as 5. So for first layer, I have options like 1, 2, 3, so on till 100. For second layer, I have only 1, 2, 3, 4, 5. So when I'm trying to form a cake which is valid, I shouldn't take these two combinations, but this one can take all these combinations. So if I ignore this one, it is going to be 99 combinations possible. And if I take in second layer this as the number, this as the color, I shouldn't take this 2 here. I can take remaining numbers except 2. Except 2, there will be again 99 numbers. In this way, if you observe, at 3 also will have 99 combination, and at 5, and at 4 and 5. So in total, this is nothing but 495. What do you observe the pattern here? The pattern you can observe is, at this point, let's say, my A is 7, A is 5, B is 7. So for first layer, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So first step, how many total combinations are possible? I can say A into B. I can say A into B combinations are possible. So here A into B is 7 into 5, 35. Minus, you should be removing the common combinations. Can I say these can be common? 1, 1, 2, 2, 3, 3, 4, 4. So I can say minus of min of AB, which comes out to be 5. So 30 combinations are possible. You can also check with this. So here the total combinations are 100 into 5, which is 500. 500 minus minimum of 105, 5, which is nothing but 495. And the same follows here. 1 into, you can say that 1 into 1, which is 1, minus minimum 0. And same follows here. 2 into 3 is 6. 6 minus the minimum 2. Output comes out to be 4. So hence this comes out to be our logic. Let's try to implement this. Let's start with the code. So yeah, I'll be using by default Java and starting with some formalities, you can say system.in. I think fast reader is not required for this. And then I need to read A and B. Int will be fine. And then I need to find total number of combinations. Combinations would be A into B. And yeah, I can, out of these combinations, I need to return I need to subtract the common ones. Common ones are nothing but min of AB. And yeah, my answer comes out to be combinations minus common. Let's see. Yeah, it works. You can obviously you can do this entire thing in a single line, but yeah, in order to make it clear, I've written 3 steps. Cool. Let's start with the second problem, brick comparisons. Chef has n bricks with him and it's numbered from 1 to n, so it's like 1 based indexing, with ith one being of size a of I. He will perform the following process. First, he picks up the brick numbered 1. Next, he looks on the other bricks 2, 3, so on till n. And if he finds the brick has strictly larger size than the brick in his hand, he drops the current brick and picks this up instead. So yeah, this statement looks quite confusing, right? So we can come up here. So let's consider this is your array. So first, chef picks up 2. This is the first brick according to chef. First, second, third, and fourth. So when he sees that, okay, 2, the first brick is of size 2. Now, when he goes to the second brick, he sees that, okay, second brick is of size 1. So my current brick, which is in my hand. So in chef's hand, you have brick of size 2. But moving forward, you have size 1. So he will just neglect it. And he will go to the third option, which is of size 4. He sees that, okay, this is currently of size 4 is bigger than this one. So he will simply drop this 2 and pick 4 in the hand. And then it is picked. Now then he goes for the third option, a brick of size 3. He sees that 3 is comparatively less size than 4, right, which is in his hand. So obviously he will ignore 3. So at the end, in the chef's hand, you're going to have a brick of size 4, but you need to print the index of it. You need to print 3. Similarly, if you come here, if you check for the second example, you have 9 and 9. So chef picks up a size of 9. He sees that okay, the next is of same size, so he will ignore it, and you have no other thing, so the output is going to be 1, the index. Then at this point you're having 2, 5 and 100. So he sees that okay, 2. So currently chef is at this point. Now when he sees 5, okay, he sees that 5 is greater than 2, so he will pick 5 now. Now chef is at here. Now chef sees that 100 is greater than 5. So he drops 5, he picks 10. At the end, chef has 10 in his hand, and you can say that it is of index 3. So the problem statement is quite simple. Let's try to code it up. Let's start with the code. So I have written a driver code here, taking the input, and according to the input format, I am also taking the input here, taking n and followed by the array elements and calling the solve function. In this, I'll be writing the main logic. So here, obviously, I need few things before the for loop. I need to keep track of the index, so I will declare a answer index initially of 0th index, and then I will be starting from 0 and iterating till the end of the array. If I can start from 1 ideally, and then if my answer index is less than is strictly less than a of idx, a of not idx, my bad, a of I, then I will be updating my answer idx with I, and yeah, at the end I can simply return my answer idx. But yeah, plus 1, since they are asking the output in the 1 based indexing, and I am following here 0 based indexing, as you can see. So let's see the output. Yeah, it's expected. It works. So yeah, you can also do this thing in the same while taking the input itself, but think that this is the best way to do it, like using a separate solve function. Cool. So the problem says that you have n fences and you want to color them. You have n total types of colored numbers. Okay, so here also you have n colors and you have n fences. Currently, all the n fences are the type 1. That means initially all the n fences have type 1 color. At the end, you want the ith fence to have a color of a of I. So what they mean is they must have given an array and they want initially all the fences are of type 1. So at the end they want the fences of this type. If they say n is 3, so there might be 3 fences. At the end they want this to be color. And when they say 6, there might be 6 fences. That means initially 6 ones. At the end they want this type. And you can do you can perform the following 2 operations, and yeah, each of the operation it will take 1 minute. So you can color all n fences at this or at the same type at the same time with type color x. Okay, where you can choose x from anywhere from 1 to n. The second operation says that you need to color a specific fence I with type x color, where you can choose x from 1 to n. So basically what they're saying is you can either the you have two operation. One is if you have, let's say, initially all are of type 1. Let's take an array of length 3, n is 3. Initially all are of type 3. So what you can do is you can you can convert all the n fences at a time to some x color. So if you see this, the second case, for this I can use this property very much. I can use this operation very much. I can convert all these ones at a time to color 3. So this can be the better use of it. And then if I go to the second operation, what they say is, if I take, let's suppose example 3, initially n equal to 6, all are 6 ones, and then the expected is 213 252, 213 252. This is the expected fencing at the end. So what they want is, they want 2 here, 1 here, 3 here, 2 here, 5 here, 2. But how can we do? So if you observe, the best way could be, choose the maximum 2 2 2. 2 has repeated 3 times, so I can convert all these fences at a time to 2. So it becomes all 2's. And then with the help of second, what they mean is, I can pick one I can pick an ith fence and convert it into, that means I can pick some first fence and convert it to the type 1 color. So I can simply convert this fence to type 1, and remaining all will be same. So yeah, this process will take 1 minute, and this process will take 1 minute, and I can use this operation 2 to convert this 2 to expected 3. So it will be like converting this 2 to expected 3, and remaining things will be same, 2 1 2 2 2. And then my next expect, and yeah, obviously this will also cost you 1 time. And then I want 5 at the last second place, so I want to convert this 2 to 5, and remaining things will be same, 2 1 3 2 and 2. And this will also cost you 1 time. And at the end I have the expected fencing. So overall it took 4 operations. So for this you need an output of 4, and yeah, which is expected. So the first property says you can convert all the fences from type 1 to some X color. And yeah, the second property says that you can pick some any ith fence and convert it to a particular color. So these are the two properties. By seeing the example, you should have understood that the property 1 should be only applied. So the property, or you can say, or what we can say operation 1 should be applied only once. And yeah, that too in the starting itself. Let's say I have converted all these to 2, I have performed some operation, I am at this stage, converting this again to any converting all these fences to some random number, it doesn't make sense, right? So instead of using property 1, or let's say operation 1 every time, you should use only once, that too only at beginning. Okay. And operation 2, once you use this at the beginning, right, then you can use operation 2 for converting. Then you can use operation 2 for rest all fences you require. For rest all fences, I can say that for rest all fences, use operation 2. So the same thing we have done in the example 2, right? The same thing we have done in the example 2. So what I can say, By observing the example 2, I can say that uh, how can I write the code for it? If you observe, converting all the fences from this from 1 to some specific color 2. Why only 2? Why? Because 2 is the maximum repeating element. Hence, I can say that my output can be my output can be 1. 1, why? Because to convert from type 1 to some maximum repeating element, and then I can say that it will be, and then I can say that it can be like whatever which is not 2. So if you remove 2, not 2 are 1, 3 and 5. I can say like n minus, or let's say not count of not 2. Here not 2 means max number, max count, or not 2 for in this case. What is not 2? I can simply replace this with n minus count of 2. Count of 2 means count of max repeated. So this can be my answer. But you might have observed one case. Why do we require this one here? This one is when you want to convert all these functions from type 1 to type some x, right? But what if instead of 2 in our example 1 is repeated max? If my example is in this way, then 1 is repeated maximum times, right? So I should not convert 1 to some other color. If this was my example, I can simply convert it like initially all ones 1, 2, 3, 4, 5, 6. So I can simply perform the operations to again and again. So it would have been like converting 3, this to 3 and this to 2, and the last but 1 to 5, and remaining all would be same. So it would have taken only 3 operations. So we need to handle this edge case. Okay, I hope you have understood the logic. So you need to handle this edge case or this one. So you can handle this edge case of 1. The edge case, what if 1 is max? We can handle this simply by n minus what we can say, n minus count for max, count of 1, I can say directly. So you need to consider, let's say, max of this comma this. Okay, let's see the code. For this we can simply use a map. A map will easily be helpful to get the frequencies of each type. So let's see the code accordingly. Okay, let's start with the code. So already I've taken the inputs here and I'm passing it to the solve function. In solve function, I would require a hash map to store my array values and the frequencies. So type integer, comma integer, array values will be my keys and the frequency will be the value. So hash map, and then I need to keep track of my maximum frequency, right? So I will keep track in the variable max rep, initially 0, and then I would fill my hash map. Hash map dot put If I have the value, fine. If not, I will put it to 0 and plus 1. And if my max rep, if it is less than my current hash value, get a of I. And yeah, it will always be have I because we are putting it before only. So yeah, max rep then will be updated to a of hashmount dot get a of I. And at the end, I would return my 1 plus n minus 1 plus n minus my max rep. But yeah, I need to also handle the case for 1, right? So I will handle it here. Math.min of. This is if I want to convert it to some other color. But what if the some other color is 1? So for that, I can handle it like simply n minus hashmap dot get our default. If I don't have a 1 color, then in that case 1 comma 0. If I have 1, fine. If I don't have any 1 color, then it will be converting it to this 0. Then I would be filling it with 0, and yeah, my n minus 0 is n. So it will be handling the edge case also. Works. Let's try to submit. Yeah. Let's start with grid max. In grid max, you are given only n value, and you have to construct a n by n grid filled with n square integers. And yeah, they have given a of ij something but I through jth column. You need to define v of j such that a of xy such that exactly 1 of x equal to y, okay, and v of ij set of all elements in the same row or same column, okay. So you must satisfy the following condition. So a of ij should be in this range, and a of j is mix of v of ij. It can be proven that there always exists again. That means they can be multiple grids, and yeah, mix of x is nothing but the smallest non-negative integer not present in S. The mix of a non-empty set is defined at 0. So this might be for the n equal to 1 maybe. Why? Because 1 cross 1, there would be nothing. Okay, so the problem statement might look confusing, but if you have understood, you might have understood this part, right? If you have come to an example, let's say 2, you need to draw a 2 by 2, you need to draw a 2 by 2 matrix such that, let's say, if I take this particular row, in this row, if I place 0, I can place from a of ij, I can place any other element, but it should not be 0. In this, it shouldn't be any 0. So I can place 1 here, 1 here, and then I can place 0. To get more idea, let's take the example of grid size 3. Okay, once again. Let's take a grid of size 3. In the grid of size 3, okay, if I can, if I'm placing some value here, I should not place the another value in this place. So in that case, I can place, let's say, 0 here. Then I should not place 0 at this place. I should place 1. I should place 2. Then in this place I can place 1 or 2. If I place 1 at this point, I should place either 0 or 2. So if I place 0 here, then I should place 2 here. So I can't place 0 here. I should place 2 and 0. Then at this point I should place 2 here, then 0, then 1. So maybe you can have some other matrix also. Maybe you can have a matrix like, maybe 2 0 1 here, 1 1, 2, 0 here. I think it still satisfies the property. So in this way, maybe you can have one more matrix. But I hope you have understood the idea. For this, you can simply keep a condition like I plus j mod n looping 2 for loops. And yeah, since if you have checked the condition, you can easily write the code for this. Cool. Let's quickly see the code. Let's see the code. So in the code, like I have already written some default driver code here, taking n and passing to a solve function. So now, according to my logic, one for rows and one for loop for columns. Whatsoever I do, I can simply do it like I can simply print instead of storing in a matrix also. That would also work. I plus j mod n and yeah, pretty much that's it. Let's run. Oh, you need to print a new line over here also. Maybe no println is required at this line. Yeah. Hope so. Let's submit the code now. Yeah, it works. Pretty simple. So in this problem, if you observe, you are given a positive integer n. In one operation, you can either do two actions. Okay. So basically, you're given some value n and you can do some operations on it. The first operation is if n greater than 2, you can change n to n minus 2. If n greater than 1, you can and n is even. So n greater than 1 and n is even. Then you can change, then you can choose to change n to n by 2. So basically, you can divide. If it is n greater than 2, you can subtract minus 2. If it is n greater than 1 and even, then you can divide by 2. So these are the two operations you can perform. For this, the conditions are n greater than 2 to do n minus 2, n greater than 2 to do n minus 2, n greater than 1, and n is even to do n by 2. And you need to find the number of different positive integers you can form if you are allowed to perform as many operations as you want, starting with n. Note that you are allowed to perform different types of operations in different types of actions in different operations. Okay, so this statement is pretty interesting. If we try to understand this with the examples, if my n is 1, if my n is 1, so I can't do any operation. Why? Because n is less than 1. So only the only different integer I can form is 1. So the output is 1. If my n is 2, what I can do is I can convert, since my n is greater than 1, I can convert this 2 to 1. 2 by 2, 2 is greater than 1 and n is even. So basically, yeah, I can convert it to, I can divide it by 2, which is 1. So hence, there are two different integers. The output here is 2. When I go to n equal to 4, from 4 what I can do? First of all, can I do the first operation? Yes, I can. 4 I can convert it to 2. 2 I can convert it to 1. Or let's not take odd integers here. Let's take only even integers. Yeah, basically what you can convert from 2 to 1. And then from 4, This I can do only by second operations, right? So let's not do second operation here, only first operation. And at 4, what I can do is I can divide it by I can divide it by 2, so again it will be 2. I can divide 2, which is 1. So how many unique elements are there? Only 3. 2 is repeated, right? So I'm not considering 2 again here. So I'm not considering 2 again here. So the different integers are 3, 4, 4. For n equal to 6 again, I can do minus 2, minus 2, minus 2. So 6, 4, 2 are there. From 6 I can convert it to 3. Again at 3 I can do minus 2, 1. And at 3 I can't divide by 2. So yeah, pretty much that's it. These are the 5 different integers that I can form. At 8, I can from 8. Again from 8, if 8 is possible, can it is 6, 4 and 2 are possible. From 4 I can convert, from 8 I can convert it to 4 by dividing. But yeah, 4 is already present. From 6 I can divide by 3, which is not present unique. From 3 I can convert it to 1. So there are these 6 different outputs that can be formed. And then at n equal to 9, from 9 I can do minus 2, 7, 5, 3 and 1. So 5 different outputs plus. Can I divide 9? No. So 9 division not possible. Now let's go to n equal to 100. From 100, if you have seen, if one maximum even number is possible, I can generate all the remaining even numbers less than 100, 98, 96, 94 and so on till 2 by subtracting n minus 2. This is by only first operation. And this count will be 50 and remaining uh, from 100, if I divide, I can go to 50. But 50 will most probably stay here. Why? Because it is also even. So I will go to 98. From 98, if I divide, what I'm going to get? I'm going to get 49. So 49, if 49 is possible, can I say for num can I say odd numbers less than 49 are also possible? 47, 45 and till 1. These are again by doing first operation. And can I say this is the highest odd number possible from 100 that I can get by doing any operation? So this count is going to be 25. So I can say in total it is 75, the required count. So if you have observed in the if you have observed, obviously we can't simulate all this. We can't do minus 2 and check all the possibilities. So instead of, why? Because my n is too high. It's practically impractical to do such thing. So if you have observed, there is somewhat pattern or some observation that you can find. If I can find the highest, if n is even, if n is odd, I can say that, okay, let's say 9. From 9, I can convert 7531, but I can't change the parity here. I can't make it even somehow. So for odd numbers, can I say the answer is going to be always n by 2 plus 1? So 9 by 2 is 4, but plus 1, why? Because 1 extra is possible. But for in case of even, in the same, in the similar case, even if I say for let's say 8, from 8 or let's say better 10, from 10 I can form 8, 6, 4, 2. So these are the first half by doing n minus 2. Now I need to find, but here there is a catch, right? I can divide 10, I can divide 8. So if I do that, I can divide 10 and becomes 5. So this is the highest possible odd number possible from 10 by dividing. If I get 5, I can get 3, I can get 1. So this will be the second count for answer in case of even. So this will be answer n by 2 plus 1, and answer, I can say answer n by 4, or maybe n by 4, yeah. But is it always dividing by 10? If you have observed, in case of 100, if I divide 100, I am getting 50, right? But 50 is already even. So can I say that if I have n, if I say n is even, for odd it is simple. This is the case for odd. But in case of even, this is the extra even count plus I can say that, okay, maybe not plus 1 required here. Why? Because uh, 10 by 2 is 5, which is the right answer. But if n is even, this is the first count and this is the second count. So if n is even, it is going to be like, uh, first thing is adding even counts, even numbers, I can say, and the highest odd number you need to get. So the highest odd number is nothing but, if you're having n minus 2, n minus 4, n minus 6 possible, then can I say that either n by 2 or n minus 2 by 2 is going to be odd? You can check in any case. In case of 198, this is 50 even, this is 49 odd. This is the maximum possible answer here. If I take another case of 102 and then 100, it is going to be like 102 here, let's say. It is going to be like 51, which is the highest odd now. So I'll be counting all the odd numbers from 51. So can I say that either this or this is going to be odd? Hence, I am directly going to add n by 4. So if you check for even, I can also say that my answer is going to be n by 2 plus n by 4, which is nothing but n minus n by 4, or I can say 3n by 4. So this is going to be your answer. In case of odd, this is your answer. In case of even, this is your answer, 3n by 4 or n minus n by 4. Cool. Let's see the code. Let's see the code. So already I have written some default code here. I'm taking the int and passing it to solve. Solve return the expected output. And yeah, let's type the code. So basically it's going to be a very simple code, but yeah, to understand the observations, it would have taken time. So if my n is even, or let's say if my n is odd, then simply return n by 2 plus 1, else, no need of else actually, return n by n minus n by 4. Let's run it. Yeah, it shows the expected outputs. Let's submit it. Yeah, works. That's it. Thank you so much for watching this video. I hope you have liked it. If you want to learn more content like this, you need to like, share and subscribe. If you want to learn DSA in depth, you can join our Smart Coder course. Thank you so much. Meet you in your next video.